Hi everyone, let's continue the lesson. Previously, we have learned how to Laplace the single equations and how taking the inverse Laplace of the equations. But now we would like to use that knowledge to solve the ordinary differential equation. Have you remember the ordinary differential equation? The ordinary differential equation of the first order has been discussed in the first chapter. And then for the second chapter, we have solved the second order ordinary differential equation. Now we would like to solve the similar or the same equation. However, for this one, we would like to use the knowledge of the Laplace transform. Alright, before we go further, you need to understand the extra knowledge that you need to have, which is when you have to Laplace the function of ft, and then you will get fs. So this is the simple one that we have been introduced to you. And if you want to Laplace the function that having the derivative of here, so you will get s and fs, then you need to minus with f0, right? Okay, so f0 basically will be given to you in the boundary condition. And then we also need to understand how to transform the f double prime into the Laplace form, which is you will get s square f s, and then you will have s f0, and then you will get f prime 0. So we will stop only until the second order, because in this syllabus we cater with the second order ordinary differential equation. Alright, okay, let's continue. Okay, if you have one question, then you want to solve dy over dt plus 2y minus t squared, where you will have been given one boundary condition equal to 1 over here. So is actually we have counted this type of equation in chapter 1, first order differential equation. However, for this one, we would like to use the Laplace transform. Okay, let's change to the general form that you have known previously, which is we can transfer to the y prime plus 2y equal to t squared. This is the question that given to you. Okay, the first step to solve the ordinary differential equation is, okay, I just list down over here, you need to take in the Laplace for each term. Okay, so means that what you need to do is, so you need to have the Laplace for the y prime, and then you need to have the Laplace for the 2y, and then you also need to take in the Laplace for the t squared. Alright, okay, so what you will get for the y prime over here, so you will get as ys minus y0. Okay, don't what we call it, don't be curious, because of previously over here we are denoted with the f, now we have the y. It's the same things, you just change to the capital Y. And then what about the y? You will have 2 is a constant, and then you will have the capital YS. And then for the t squared over here, we have been counted previously, where you will get 2 factorial, and then you will have s power of 3, which is 2 factorial equal to 2, and then you have the s3 over here. Okay, so what you need to do is you need to list down and replace with the asking question for you, y prime. So you will have y sy capital minus y0 over here, and then plus with 2ys over here, and then over equal to 2s cubed. All right, so what you need to do is you need to replace the given boundary condition where the y at t equal to 0 is equal to 1. So this one is 1. All right. Okay, so this is the only one that you need to replace. Okay, so let me write again to you. We have plus 2ys, and then I have 2s cubed, and then I bring the negative one to the right hand side, becomes 1. Okay, now I need to factorize the ys, where I will get s plus 2 over here, and then this one remain like this, and then just finding the ys and then bring the s plus 2 to the right hand side, so you will have 2 over s cubed s plus 2 plus 1 over s plus 2. Okay, all right, so you have done your first part. You find the ys. All right, okay, so now in order to solve the given equation over here, so as I said previously, what's the meaning of the solve means that you need to find yt. All right, you need to find yt. Okay, so how to find yt from ys? Okay, you have learned previously, from the s to get the t, what you need to do is you need to inverse. All right, you need to inverse the term over here, because of when you inverse this one, all right, you will get the yt over here. Okay, so you will get 2s cubed s plus 2, and then you will need to inverse, okay, 1 over s plus 2. So basically this one you may get directly from the table. However, for these terms, you have to apply the knowledge to solve this one. All right, okay. So now this one, I believe that you will get exponent negative 2t directly. However, for this one, okay, we need to apply the partial fraction. Okay, let me solve it separately. So if you want to have 2s cubed s plus 2 over here, so remember the term, this one is a linear or not? All right, it's a repeated, right? Repeated linear. So I have a over s plus b over s squared plus c over s cubed, and I have another term here is d s plus 2. So this is the partial fraction form that we need to solve. Okay, so do you think it's a very difficult? Okay, it's okay. You just continue finding the answer. Okay, so as I said to you previously, we need to matching with the left hand side. So the left hand side we have 2. So look at this term. So this term is lacking with which term? So that it will become just like the denominator of the left hand side. So we already have s over here, so we need to multiply with s squared and s plus 2 for this term. For the b, we already have the s squared, we lacking for the s and s plus 2. What about the c? C, we already have s cubed, so we need to have to multiply with the s plus 2. And then the d, we already have s plus 2, so we need to multiply with the s cubed. All right, okay. So what we need to do is we need to expand one by one so that you will see very clear in order to match with the left hand side. Okay, so you will have as cube, okay, plus 2as squared plus bs squared plus 2bs plus cs plus 2c and then plus ds cube. Alright, by looking at this one, so you need to gather. Okay, let's go for the highest of s first. So the highest of s, you will have this one and this one, which is there is no term for the left hand side. Okay, for the right hand side, we have a and d. Alright, okay, what about the s power of 2? Look at here, you have power of 2 and then power of 2 over here. Also, there is the 0 and there is no term for the left hand side. You will get 2a plus b. Okay, what about the s power of 1? And then s power of 1, okay, we have, okay, 3 terms over here. Okay, so also you have, okay, look at here, you will have 0 and then okay, where is the, okay, which one is incorrect over here? So we have b, we have cs and then we have 2c over here, class. Okay, 2c. So we have a and d is correct for this one. For the square over here, we have correct for this one. What about this one? We have only, okay, 2b and plus c. 2b and plus c. Correct for this one. And then only left with this one, which is the single number. You have 2 for the left hand side and then you have 2c for the right hand side, where you can get the c over here is equal to 1. When c is equal to 1, so you will get your b by substituting the c over here. So you will get your b is what? You will get your b is negative 1 over 2. When you get b, you will get an a. So what is your a? So your a is 1 over 4. Alright. Okay, so you will get, a is 1 over 4 and then the d, when you substitute your a, you will get d, which is, okay, what is your d? What is your d when you have a is equal to 1 over 4? So alright, so you have to check back which one is wrong. Okay, because of the okay, look at here, class. What you will get is, okay, you will get, d is negative 1 over 4, right? Negative 1 over 4. Okay, so now you replace back into the your partial fraction form, whereas your a is 1 over 4 and then you will got, okay, 1 over s here. You will have b your b is negative 1 over 2, and then you will have s squared, and then you have c plus you will have 1 over s cubed, and then the last one you have d, which is negative 1 over 4. So you will get s plus 2, 1 over s plus 2. Okay, so by taking the inverse for each term, so what you will get here 1 over 4, and then you will get here negative 1 over 2t, and then for this one what you will get is you will get 1 over 2t squared. Alright, and then for this one you will have 1 over 4, and then you will have this one is exponent negative 2t. Okay, the answer that you get over here is actually only for the term of the partial fraction. And then the final answer, you need to combine with the term that you already have previously. 1 over 4, I put in one term, 1 over 2t plus 1 over 2t squared minus 1 over 4 exponent 2t, and then you need 2. Alright, okay, so you need to multiply with exponent. Okay, you need to plus with exponent negative 2t. Okay, so what you will get over here, because of these terms and this term can be combined together, so you will get 1 over 4 minus 1 over 2t plus 1 over 2t squared, and then negative 1 over 4 plus 1 plus 3 over 4 exponent negative 2t. So this is your final answer. Okay, you might go with a different way, however you will end up with the similar answer. Alright, okay, thank you.